Hey Dr. Horn, it's David here, doing chapter 15 video assignment. The question starts off with saying, for each of the following salts, find under which conditions would salt dissolve in best, an acidic, a basic, or it doesn't matter. So the most important concept to understand of this assignment was the strength of the ions. If we can determine the strength of these ions, then we can determine what solution the salt would dissolve best in. So if we have a strong acid or base, then we know that its conjugate pair is going to be very weak. And if we have a weak acid or base, then we know its conjugate pair is going to be weak as well. So diving into the first one, we have barium carbonate. It splits up into the two ions, barium and carbonate ion. Looking at the barium, we can see that it has a 2+ charge, which tells us it has protons to donate. So its conjugate pair is going to be barium hydroxide. Barium hydroxide is, as we've looked in the book, is a strong base. So because this is a strong base, and if we're following the rules that we did in class, and barium is a very weak acid. Going over to the carbonate ion, it has two protons, it has an ability to accept protons, and so its conjugate pair is going to be carbonic acid. Carbonic acid in the book is a weak acid. So since it's a weak acid and we're following the rules, its conjugate pair, the carbonate ion, is going to be a weak base. Now comparing the two, we have a weak base and a very weak acid. We know that the carbonate ion, because it's weak, is stronger than the very weak acid, meaning that the barium ion has very little to do with what's going on in the solution. So this will prefer the weak base, and it would dissolve best then in the opposite. So it would dissolve best in an acidic solution. Following the same path and thought pattern, we take it into number 2, which is our lead bromide. It splits up into the two ions, lead and bromide. Lead has a 2+ charge, telling us it has protons to donate. So its conjugate pair is going to be lead hydroxide. Lead hydroxide in the book is a weak base. And so its conjugate pair is going to be a weak acid. So that's what the lead ion would be. And going over to the bromide ion, we see that it can accept some protons. So its conjugate pair is going to be hydrobromic acid. And then hydrobromic acid is a strong acid. Knowing that this conjugate pair is a strong acid means that the bromine ion is a very weak base. Once again, comparing the two ions, we see that this one's weak and this one is a very weak one. So we follow this, and since it's an acid, we have to do the opposite of it. So it's the best solution that it would dissolve in would be a basic one. Finally, on the last one, we have barium sulfate. Barium sulfate splits up into its two ions, barium and sulfate. Here we see that barium has two protons to donate, so its conjugate pair is barium hydroxide. As we've seen in the first one, barium hydroxide is a strong base, meaning that this barium ion is going to be a very weak acid. Then we look at the sulfate ion as well. Sulfate ion has protons to accept, so it's going to turn into its conjugate pair, which is sulfuric acid. Sulfuric acid is a strong acid, meaning that this sulfate ion is a very weak base. Now, since we have our ions and we've determined their strength, that they're both very weak, then we can come to the conclusion that the solution that it prefers is neutral. It can go into either one, meaning that if we put it in a basic solution or in an acidic solution, they're both going to dissolve very little but at equal rates.